These are the notes for AP Calculus on the topic of limits at infinity and horizontal asymptotes continued. So let's take a look at a real-world application of these limits at infinity. This one says we've got an invasive insect species spreads at a rate given by C of t, and the units for that rate are acres per day. And our variable here is t instead of our usual x for all times t greater than 0. So it says write a limit expression that describes the end behavior of this rate. Okay, so end behavior is talking about limits at infinity or negative infinity. So normally it could be either one or both, but in this case it's time, and having negative time doesn't make sense. Plus, it also tells you time is positive here. So the only limit expression for the end behavior that would make sense here would be the limit as t approaches positive infinity. So as time goes on to infinity. And then you can either write the actual equation here for c of t, or you can just write c of t for short. Either way is fine. And so that's the first thing it asks us for, to write that limit expression that describes the end behavior. That would describe the end behavior. And then it says to evaluate this limit expression. So to evaluate it, it works just like if the variable is x. Since these are polynomials on the numerator denominator, you look for one of the highest exponent. So in this case, it's 7t squared. So that would go on the numerator. So it would be 7 infinity squared is what's going to matter on the numerator. And then you look for the term on the denominator with the highest exponent, which is 21 infinity squared. And in this case, since the infinities have the exact same exponent, they completely reduce out there. Or you can see if you subtract 2 minus 2, you get infinity to the 0, which is 1. And then 7 over 21, that reduces to be 1/3. And then the units, since they're given to us right here, would be acres per day. So what that would mean in the context of this problem would mean that as time keeps going on to infinity in this case, eventually the rate's approaching 1/3 acres per day that these invasive insect species spread out. And that concludes the notes for AP Calculus on the topic of limits at infinity and horizontal asymptotes continued.